Hello and welcome again to another video on this quick intro and recap of TCP/IP. Especially this is the network. This course is for network troubleshooting TCP/IP course. Network troubleshooting for software engineers, okay, or for server people. Network troubleshooting for for software engineer. So this course is taught by Chris Greer. Shout out to Chris Greer. So the goal of this is, well, to understand and be able to communicate why and what TCP and IP does using Wireshark for network inspection. Something that is very useful, especially if you're a software engineer or if you are, for example, someone that is here on the server or the application level, and you want to know is what's going on here. So why am I doing this? Especially because as you move on your career as a software engineer, and also something that Chris Greer mentioned, right? So because in his case he started as a network engineer, so from the low level layers of the OC models, and this OC model is just a standard of how different computer systems communicate each other. So the OC stands for Open Standard Communication or Interconnection, or Open System Interconnections. And that's the whole point of this, is that how can I make a different computer system? It means that different arrange or configurations of hardware, software, and different peripherals and equipment, okay, whether it's from a mainframe or for supercomputer or mini computers or microcomputers, laptops, OS like Windows, Mac, Linux. How can we, make all of these different computer systems that the whole idea of them is that they are capable of processing data, right? How they can communicate each other. So because of that, Chris, he started as a network engineer. So this kind of people are responsible for handling his cables and network and routers and switch. So make sure that the data get from there to there in a reliable and with low latency for so. So that's the whole point of these network people, according to Chris Greer. Okay, and then we have is the server peers, like me, the application guy, the servers peers, people. So they are now responsible for looking at the server and the process and the applications and the virtual environment, and they live in this little world, all right, which is something that I live in, right? So I'm thinking about is the application that is running in the proper process. How many process are we using? The virtual environment, and also using tools like Dockers, and if we are using is the proper resource, and how if we're efficient with a resource, and if there is no spike or weird process running in the background, okay? But now when there is an issue on this communication, Okay. Um, Most of the time, people from the network and the server actually fight each other. So something that Greer, Chris, let me recap his name. Chris Greer mentioned that he remembered that he was at a place at a conference in a company where you have is the Microsoft guys and the server people, then they fight into the network people, uh, but then suddenly comes the package guy to say, okay, what's going on? Look at this, look at the Wireshark, and they understand that and say, okay, I know what it's doing, and then fix that. Bam, he did it. So the whole idea of this, as a server guy here, is to avoid the way of fighting here and try to solve these particular problems. Why is that? Because the transport layer, well, according to Chris, uh, Jesus, Chris Greer, is like green but with air. Chris Greer mention is that on the transport layer you can see which layer or which is where the problem come from, right? Because if you can guarantee that the package reach, there is, for example, problems if the network is highly congested or there's some package loss, then you can take a look at the network layer. However, is now the problem is, for example, uh, on so if the problem is not in those fields, so you can make sure that actually the package sends and reach to the destinations, and they even though that TCP is a protocol that is smart enough to sense if to sense the congestion, to sense the network congestion, and also the to sense the network congestions, and if we in this if there is some um, missing package, right? So TCP say, hey, I'm gonna slow down, I'm gonna back off a little bit uh, before sending. So the whole goal of this TCP or the transport layer here, especially for large data sets, it says, hey, I want to I want to know what it will be the best rate that I can send that data at without running into any issues. That is very enlightening. Whether it's you are on the network, if you are part of the network, if you are in the part of the network house or the server, because now you can do a lot of this troubleshooting. So that's interesting, and that also opens up a little bit of perspective. Chris Green also have another interview with someone that I don't remember that, but he has that in their interview in their channels when he talk about people that go in the Cisco or the CCNA, this Cisco certification, which is this. I'm not sure what Cisco Certified Network Associate. Okay, even in on the name it tells you what they're gonna do. So in this CCNA is more for network people, and they don't show you anything like the transport layer. So yeah, the whole point of this is to try to end this, and whether it is the network or the server guy knows about this layer, as a way to do a faster troubleshooting and identify where the problem comes from. Makes sense. Makes a lot of sense. A lot of sense. A lot of sense. So in today's video, I'm gonna take a look now is at the core concept of the TCP like handshake and options, TCP windows, retransmission, and selective acknowledge. Then we're also gonna look at the tips for isolation performance issues like creating a TCP profiles, colors, filter tips in Wireshark, filter expressions, spotting delays in TCP, and then the case study for that. Okay. The whole point of this is to make myself familiar with Wireshark and as well as the concept, because once you know the fundamentals, you can easily solve problems. That's exactly what I did with the React course here. So the complete React core and something that I'm doing right now with the intermediate React core. Like so, what is this? Complete intro to React, what? Complete intro to React, what? Why is this? What? Anyway. Okay, why in the F? Of course, get out of there. What the hell? Why do you have? Anyway, so yeah, it's pretty much with React, which is a course. This course was taught by Brian Hall. Again, this might be all. This is quite off the realm from this course, but the idea here is to once you're able to recognize is the core concept, especially with React, okay, as well as even though with React advanced topics. So once you're able to recognize is the core concepts, pretty much with this, you are now be able to solve that issue, and you now, hey, what was the name of the guy that solved this, or the girl that solved this? Okay, it's gonna call him or call her. All right, good. So here we are. So this is the TCP.
First, how does TCP start its conversation? We've seen it so far today.
Okay. So how TCP start it is conversation. Okay. So remember that after all, TCP only cares is, so TCP is this protocol that wants to figuring out what is the best rate at what is the best rate that I can send that data at without running into any problems. And to do that, I need to connect that, which is make this TCP, make this protocol connected oriented. Yep. Okay. Connected oriented. So unlike IP, where this protocol is connectionless, okay, so you can send package even though even though if someone is on the other side or not. With TCP, as a way to guarantee, because after all that's what TCP does, is to guarantee that you're going to send the data, and the data that you're going to do that is, or the data that you're going to send, you can do that at the most faster rate possible without running into any issues. Okay, so you can sense the congestion of the network, and if there is some missing package, you can going back here or back off a little bit. So because of this, you need to establish is a communication, is a handshake or a conversation. Okay, so because TCP, unlike IP, is a connected oriented is a connection, or is a connection based protocol. Okay, so I can ask here IP and what is the difference? Yep. And what is the difference? TCP is a connection-based protocol. Exactly. IP is just, so IP only cares, okay? So IP only cares of sending and routing package of data through the network. Hey, I'm gonna send this package, and then I'm gonna route this. Hey, this route, this another route, okay? I don't care if that actually reach. I don't care if the data I don't care if the data rich, I don't care if the data is duplicated, I don't care anything of that. Its only handle is the data. I'm just only handle is that the data is sent and it can take the proper route until it is destination. That's all. Whereas the TCP guarantee that the data that you send from the client and the server from these computers, okay, actually reach it. There is an acknowledgement, there is a handshake, there's a conversation in there. So okay, so because TCP, unlike IP, is a connection-based protocol, okay, which means, so you can send that so which means it is So which means is it start a conversation, okay? So which means start a conversation, start a reliable conversation between two servers, okay, between two computers or servers, okay, between two computers, okay, or servers, okay, because TCP is responsible, is this protocol that say, hey, let's going to actually establish a conversation here and make it reliable. So by guarantee that this conversation is fast and fluid as possible, or in other words, is that by figuring out as a TCP protocol what is the best way that I can send data at without running into any issue. Now the question is how this work, okay? So because TCP, unlike IP, is a connection-based protocol, which means it starts a reliable conversation between two computers or servers. Exactly. Since TCP wants to figure it out, yeah. And since TCP wants to figure out what is the best rate at which, what is the best rate at that I can send data at without running into any issues. All right. Okay, so TCP wants to figure out what is the best rate that I can send data, whether it's the high throughput, okay? What is the best way that I can send data without running into any? What is the best rate that I can send? What is the best rate that I can send data at without running into any issues? So question is. So now the question is, how does it work? How does it work? You know. How does it work? Here we are.
First thing we gotta do is handshake.
Mm-hmm. First things we gotta do is handshake.
All right, we're going to spend some time talking about the TCP handshake. What's in it? What can we learn from it?
Okay. What's in it? What can we learn from it?
Those first three packets, which are so critical, we've heard that from sessions previous to this one. Make sure to get the handshake. Make sure to get the handshake. Okay? We're going to take a look at a couple of trace files that have some handshakes, see what we can learn, look at those options, see what they mean. And we're also going to look at a trace file that was missing a handshake and see what we are missing from a file that was missing those options, see what they mean. Does it have some handshakes? See what we can learn, look at those options, see what they mean. Trace file the handshake. Make sure to get the handshake. Okay? From it. Those first three packets, which are so... What's in it? What can we learn from it? Those first three packets, which...
Okay. Those first three packets. So this is the anatomy of this.
They're so critical. We've heard that from sessions previous to this one. Make sure to get the handshake. Make sure to get the handshake. Okay? We're going to take a look at a couple of trace files that have some handshakes.
those first three packages, make sure to get the handshake, because this is what is going to establish this connection.
Shakes, see what we can learn, okay? We're gonna take a look at a couple of trace files that have some.
Okay. We are going to take a look at a couple of trace files.
Handshakes, see what we can learn, look at those options.
Okay. See what we can learn. Look at those options. I don't know what option means in this context.
See what they mean. And we're also going to look at the trace file that was missing a handshake.
Okay, look at those options. See what they mean. And also look at those packages.
See what they mean. And we're also going to look at the trace file that was missing a handshake.
Okay, we also look at the trace files were missing the handshake, and also look at the trace files were missing the handshake. Okay,
and see what we are missing from that stream.
And see what we are missing from that stream. Okay, we're not only gonna look at how to make the handshake. Okay, this the first step on the TCP connection, the mechanism of how this works. Not only that, but also look at trace files we're missing. Look at trace files missing the handshake. Look at the trace file missing the handshake and see what we're missing from that stream. Interesting. It's not only make sure that it's not only look at the handshake itself, how that worked, but also what went wrong when doing the handshake. Okay, looking at the trace file and see what we're missing from that stream. Again, troubleshooting. So understand the mechanism. Understanding a success. Understanding a success case and the error case. All right. In other words, understand a success case, understand a success and error case, and what can we do?
What can we not tell about that conversation because we missed the handshake? Okay? Can we not tell?
Okay. And what can we not tell
about that conversation because we missed the handshake?
And what can we not tell about that conversation because we miss the handshake?
Okay? That's where we're going with this. Now to put it simply for you, this client wants to talk to that server. It wants to get something from it. It wants some piece of information.
Okay.
Wants to talk, we're going with this. Now to put it simply for you.
Okay. To put it simple, the client.
This client wants to talk to that server.
Yeah. To put it simple, a client wants to talk to a server. Okay?
wants to get something from it.
It wants to get something from it.
Wants some piece of information.
Yeah, want some piece of information.
Before it can do that, it's got to do its handshake thing, right?
Mm-hmm. So before it can do that, it needs to do a handshake first. Screenshot here. Da, da, da. Computer History Museum, Mountain View, California. June 25, 28. That's interesting. That's interesting. Oh, I love it. No, man. Okay.
3 packets, TCP SYN, SYN-ACK, ACK, and then it can go on and do whatever it was it wanted to do. Hey, give me.
Okay, TCP SYN, SYN-ACK, and ACK. These 3 packages sent. These 3 steps that is doing as a way to establish a connection as a TCP. As a way that, hey, and now the connection is establishment. Hey, now we can talk about it.
That picture, give me that file, give me that thing. Okay, here you go. So those 3 packets, that's.
Okay, makes sense. So TCP SYN, SYN-ACK. I think this is very, very important, man. Jesus. Yeah, I think it's very, very important for server or network people. So TCP SYN, SYN-ACK. Okay, TCP SYN. Hey, let's go to sync, bro. Or girl. TCP SYN, SYN-ACK, and then ACK.
We're gonna focus. Give me that thing. Okay, here you go. Whatever it was it wanted to do. Hey, give me that picture. Give me that. Hey, 3 packets, TCP SYN, SYN-ACK, ACK, and then it can go on and do whatever it was it wanted to do. Hey.
And then it'll do.
And then it can go on and do whatever.
Okay, and then it can go on and do whatever it is. Hey, send me a image or an HTML file. Hey, send me an image or HTML file, an audio file, data.
Whatever it was it wanted to do. Hey, give me that picture, give me that file, give me that thing. Okay, here you go.
And the server can say, okay, here we go. Here you go. Which is this. I didn't take a picture of that. Bullshit. Really? Interesting. Okay. Right. But this is exactly what's happened anytime you want to communicate to a server And before actually sending data, and to put it simple, anytime you want to communicate to a server, to the data, you want to get some information of that or send that, a handshake needs to be done. That's interesting. Is this handshake happens anytime that you want to talk to that, or you can establish is for how long you want to keep this session? That's when it comes this thing, this system part. Say how long you want to establish this communication. Makes a lot of sense. Okay, now that goes from my layer as a server. Hey, for how long you want to keep this conversation?
So those 3 packets, that's where we're going to focus. Now, if this is a review for you, great. If there's something you can contribute to what I'm doing up here, hey, I like this part of the handshake too. Cool. But this is meant to be a review for you. Okay. Enough PowerPoint. I'm not a PowerPoint guy, so. In fact, this morning I opened up my presentation and I found that every single image that you see on this presentation was missing. It was gone. From the shark fin to everything you see. So I had to rebuild it back there about an hour ago. Anyway, okay, let's go ahead and go to our handshake.
What is that?
So, let me get set up here.
Oh my God, what the hell is that? Do I have access to the handshake there? To that package? Can I have access to that package?
Sure. Okay. All right. So first, when it comes to Wireshark, let me. Okay. Now, something that I always need when someone else opens up their Wireshark is I need them to talk me through their screen. Just talk me through what you got here, talk me through your profile. So I'm not going to assume you've seen all these columns and all that stuff. But basically, so for me, I like to create, you can't see it down here, it says TCP plain. This is just my plain Jane default TCP profile. As you can see, it's not that fancy. It doesn't have a lot of extra information in it. If I need all that other stuff, cumulative bytes, calculated window size, bytes in flight, if I want all that stuff, I can flip my profile. But at first, sometimes that stuff makes me dizzy.
Okay.
All right? And especially when I'm looking at somebody else's screen. You know, I see what all the columns they have, and I'm like, whoa, okay, hang on a second. That's also for me, sidebar. Sometimes in my classes, people say, oh, you know, show us your profiles. What kind of profiles do you have? And so I'll bring up my profiles. I'll go, oh, there's all my profiles. Oh, can we have those? That'd be great. No. You can't. Why? Like Hansong said yesterday, this is my way. And in my world, in Chrisland, it's my way or the highway, right? This is how I analyze my setup, my configuration. Unless you built all of those profiles, how do you know what they do? Right? So that's for me. I tell my students in my classes, don't use anybody else's profile. Build your own, because then you know exactly what you did. Right? So for me, I've got TCP plain, I've got TCP advanced, I've got TCP Windows. Depending on what I'm troubleshooting, I'll use one of those, at least first, right? And then we'll go off into the specific protocol stuff. Now let me tell you a little bit about TCP plain. Now for me, one thing that I like to do that's not default, for me, I used to hate the colors, so I just turned them off, but I started getting used to them and they grew on me. But you'll notice one thing for me that I like to do is I like to paint the sins green. See, up at the top. So one of the first things I do, go into my coloring rules, I create a new coloring rule, paint it bright green, tcp.flags.sin equals 1. Okay, that'll paint all of your sins 1. I want to paint them green. I want to see them. I want them to jump out at me. That's a personal preference. Also, as you've heard in other sessions, delta time. Okay, so I like to add a delta time column. I like to do that almost for every single profile I have. Hopefully that's something that you have in your profile as well. Now to quickly do that, I know we saw that yesterday, I just want to make sure I don't want to leave anybody out or behind or anything. I'm just going to go to my preferences, I'm going to go to my columns. I just like to manually add it when it comes to delta time. So I add a column called delta time displayed.
Okay, so now it's time for us to take a look actually to the Wireshark. Like so. Okay, so right now we got is the default profile. Interesting. So in the default profile we got is this. Holy moly. Interesting. Okay. And they got is the delta time. What is the difference here? How long is that client and server here? If you're evaluating the loopback, it doesn't matter. It's nothing wrong with that. Okay. And this is just to show is all of the interface here. This is from the look back.
Okay. I move it up next to the time column that I can then change to running total or time of day or whatever, but that delta time is an important one. I'm not going to talk about this right now. In fact, I'm just going to kind of close it up a little bit. This up here, it says time since previous frame in this TCP stream. Now for this trace file, this is one TCP stream. So that column and the delta column are the same. All right? So you might be thinking, well, Chris, why do you have a redundant? It's the same thing. Because I'm going to get there. I'm going to show you guys why you would want to add another time column and how that's useful for you in spotting delays. But, okay, I'm going to kind of close that one up for now. Okay, so let's do a little bit of digging. So that's my basic TCP plane setup. I also do have some buttons up here. Bad TCP, no broadcast chatter, slow HTTP. I've got a handful of other ones. But basically, those are my quick filter buttons. Okay, so SYN. Let's take a look at this handshake and let's see what we can learn from it. Okay, so the client has initiated a SYN to the server. This is port 80. Let's go ahead and take a look at what we can learn. Now, hopefully everybody can see this. I'm going to blow it up just a little bit more. All right. Okay. Layer 2, I'm going to jump it. Layer 3, for now, I'm going to jump it. We see our IPs. Let's just take a look at TCP and what we can find here. All right. Source port, 61330. high client-side port number, dynamic, client-side ephemeral port. I'm not too worried about that right now. It's just a high number port. Great. Destination port, the guy I'm going to talk to. Stream index. Now Wireshark does a nice little thing. You notice, maybe you've heard this in a different session, but anytime you see a value that is in brackets, those hard brackets, that is a Wireshark value that it has done. That's not part of the data. It's something Wireshark does to help us interpret what we're seeing.
Okay. Just gonna slow down a little bit here because there's a couple things going on, especially here. Okay, from now, Chris. Okay, I think I wrote it. Chris with H, I think. Chris with H. So I got is this. So from now, Chris show off is the. So from now, Chris show a trace file on Wireshark. Okay. From now, Chris show a trace file on Wireshark. Okay. And basic profile. Okay. And the basic profile to set up to identify a couple things. Handshake, delta time, the difference between the package that was sent and the package received. Delta time is also something that he mentioned.
And for now, I'm going to jump it with CRIPs. Layer 2, I'm going to jump it. Layer 3, for now, I'm going to jump it with CRIPs. Let's just take a look at TCP and what we can find. Just a little, we can learn us into the server. This is port 80 from it. Okay, so TCP, no broadcast chatter. Okay, so you would want to add another, because I'm going to get there. I'm going to show you, Chris, why do you have a redundant? It's the same thing. Because I'm going to get there. I'm going to show you, and the delta column are the same.
Exactly.
Now for this trace file, this is one TCP stream. So that column
for this file is one TCP stream.
And the delta column are the same.
Time since previous frame in this TCP stream. Okay. Time since previous. Okay. So time since previous frame in this TCP stream. Time since previous frame in this TCP stream.
All right? So you might be thinking, well, Chris, why do you have a redundant? It's the same thing. Because I'm going to get there. I'm going to show you guys why you would want to add another time column and how that's useful for you in spotting delays. But, okay, I'm going to kind of close that one up for now. Okay, so let's do a little bit of digging. So that's my basic TCP plane setup. I also do have some buttons up here. Bad TCP, no broadcast chatter, slow.
Bad TCP, no broadcast chatter, and show HTTP. Bad TCP, no broadcast channel, and no broadcast chatter, and show HTTP. And show HTTP.
Slow HTTP. I've got a handful of other ones, but basically those are my quick filter buttons.
Okay, but this is quick filter buttons. Okay. Handshake, dial time, and SIMs. On the table, Yep. And as filters,
Okay, so SYN. Let's take a look at this handshake and let's see what we can learn from it.
the question is that he also have a lot of profile. Okay. Okay. Handshake delta time times sync with greener color. Okay, greener colors. Delta time times its previous frame in TCP string. Okay.
Okay, so the client has initiated a SYN to the server. This is port.
The question is that how can I take a look at this? Okay.
80. Let's go ahead and take a look at what we can learn.
So for example, in our particular case here, because all of these are TCP, and then he color up this TCP ACK unseen segment. All right, and this is a source port from that. And okay, I want to now, for example, okay, and now for example here, okay, it's like how how to filter in Wireshark. Okay. So in this particular case, we're gonna do is a TCP. Oh look, it'll also show you this. But in this case, is whether it is this. Yep. Okay. All right. Exactly. Which is here. So in this particular case, that's what we're doing. And we're gonna do this because this is the port we want is to actually filter. So it seems that so far there is none of that. Okay. And what I can do is say something like this. And that is, hey, I would love to run that server, which is our e-ticket per se. So what is the e-ticket running? We are running is a client, and we're running is the exactly. So let me now here is run this particular server. That's quite interesting. Okay, and then once the client wants to establish that connection, in our particular case, how do we, okay. Like so, there you got it. All right, okay, chill, bro, chill. Chill. Okay. Cincinnati Act. You know, we are now able to see properly is here, right? Cincinnati Act in this case. And there you got it. All right. As you can see, it's doing the sync. If you take a look at here, hey, this is the guy I'm gonna talk to. No, this is the guy I'm gonna talk to. This is me. The client and the guy I'm gonna talk to. Interesting. They're using his internal port here to actually establish this connection. And this is something that the OS doing behind the scenes. What this So ports that go from 49, 152, and go on are dynamic ports. Are dynamic ports that are being used by the application to say, hey, you know what? I'm gonna open this little door as a way to establish this connection to the server. In this case, the server we're running is on the same computer, okay, which is here. You know, it say, hey, this live in the same computer, okay, and because this live on the same computer, we can say, hey, is there any reason that I can do, for example, on the preference here, find a package, go previous, automatic scroll generation. What? No, but you got Wireshark. Okay. All right. So this is the file here. Edit, view, blah blah blah. Show packet in a new window. Go and capture. Okay. Analyze. In my case, is on how do I configuration profile. Quite close, but not. File set. Where did he access to that? Analyze. Okay, let's go back here to the video. Okay, how did you access to this? Okay.
I'm just going to go to my preferences.
Okay, preference. It's interesting. Wireshark preference. I think it help. Content. How the F do I find preference here? There you got it on Wireshark. Okay. Command that. Okay. Command point. You got it. Cool. And here is what you say in the columns. What's going to add is the delta. So delta time. So delta time. Okay, and this is a delta time display. So now let me put it close to this, to time. The delta time, and here we can see how long those packages actually took, and the way how it. Okay. So because now how long it took, you can say, hey, this is when you do the Cincinnati Act, all right? And this actually took like, what is this? How do you read this? This is not millisecond, this is like microseconds, 71 microseconds, blazing fast. All right. It's quite interesting that is able to measure that. All right.
I'm going to go to my columns. I just like to manually add it when it comes to.
Okay. Let me. In fact, I should do something here. Put Wireshark here.
Delta time. So I add a column called delta time displayed. Okay? I move it up next to the time column that I can then change to running total or time of day or whatever, but that delta time is an important one. I'm not going to talk about this right now. In fact, I'm just going to kind of...
And as you can see here, okay, the delta time is because now they are in different computers. There are two different computers actually communicating. This delta time is blazing. It took quite a while, you know.
Close it up a little bit. This up here it says time since previous frame in this TCP stream. Now for this trace file, this is one TCP stream. So that column and the delta column are the same. All right? So you might be thinking, well, Chris, why do you have a redundant? It's the same thing. Because I'm going to get there. I'm going to show you guys why you would want to add another time column and how that's useful for you in spotting delays. But, okay, I'm going to kind of close that one up for now. Okay, so let's do a little bit of digging. So that's my basic TCP plane setup. I also do have some buttons up here. Bad TCP, no broadcast chatter, slow HTTP. I've got a handful of other ones. But basically, those are my quick filter buttons. Okay, so SYN. Let's take a look at this handshake and let's see what we can learn from it. Okay, so the client has initiated a SYN to the server. This is port 80. Let's go ahead and take a look at what we can learn. Now, hopefully everybody can see this. I'm going to blow it up just a little bit more.
So, in this particular case, because we're running is our server locally, it say, hey, the port was 528083, which means it's a dynamic port. And this application, in this case the browser, is actually using dynamically as a way to communicate to that server. In this case, this Docker instance, which hosts, which live on 5002. Okay, is this. So far so good, and as you can see, the delta time is pretty much yesterday.
All right. Okay. Layer 2, going to jump it. Layer 3, for now, I'm going to jump it with your IPs. Let's just take a look at TCP and what we can find here. All right. Source port, 61330. High client-side port number, dynamic. Client-side ephemeral port. I'm not too worried about that right now. It's just a high number port. Great. Destination port, the guy I'm going to talk to. Stream index. Now, Wireshark does a nice little thing. You notice, maybe you've heard this in a different session, but anytime you see a value that is in brackets, those hard brackets, that is a Wireshark value that it has done. That's not part of the data. It's something Wireshark does to help us interpret what we're seeing. Now we see here stream index.
This is things like they mentioned here. So, for example, is this screenshot that you got it. So square bracket here, square bracket here is something that Wireshark add to help users to read, to understand package better.
0. So this is the first stream of any kind that we see in this trace file. If I saw a SYN and a SYN right after it on a different port number, that would be stream 0, stream 1. Right? So you can quickly spot how many different TCP streams do I have in this trace. We can go up and look at conversations if we want to. TCP segment length. How much data is in this packet that I'm sending? As we see, none. Sequence number, 0.
Okay. Sequence number, bro. So okay, sequence number 0. Okay, string index. It is interesting because string index, something that here we are sending, by the way, and we're doing the syncing act. Strings index like this is like, oh, okay, that's interesting. Okay, as well as the TC segment length and sequence number.
We're going to talk about sequence numbers and how to run through that and how sequence numbers work. But basically, what Wireshark does is it will start this sequence number off at 0 for me. If I select that field, let me go to sequence number. I'm going to come over here to my hex. So a sequence number, just to boil it down, a sequence number is a number that increments as I send data. Okay? If my sequence number goes up by 1, it's because I've sent 1 byte of data. All right? If it goes up by 100, then I've sent 100 bytes of data. I've got a positive acknowledgement back for that data. It allows TCP to figure out what actually got there, where am I starting from. In this, in the packet train as it leaves, what's missing, how do I fill that back in? That's because every byte that I send has a sequence number assignment, if you will. We're going to look at how to count that and how that works in another trace file. But Wireshark figures, well, by default, as human beings, we have a better time starting off at the number 0 than we do some long, crazy 4-byte number. If I select the sequence number value here, look at my hex. That's actually a 4-byte number, 65B4940E. Is that 0? No. That's an actual big, long, scary-looking number. But as a human being, I have a tough time making that number my starting point. Right? I like things to start at 0, and it's easy to count up, and I can see how much data went and how much has been acked. For that reason, by default, Wireshark will do relative sequence number, meaning, don't worry about that long, crazy number, Chris. I got you. This is just going to start at what we'll call 0.
Mm-hmm.
Now, that's something that I can take off if I want. If I want to see that original starting value there, that's a TCP setting. I can always bring it back if I choose. I just right-click TCP, come into protocol prefs, and then I can come down and I can uncheck relative sequence numbers. That'll make that scary number come back. Now, some people would say, that's the one I want to see. Boom. For me, it's a long, scary value that it's just more work for me to do. I'm all about making less work for myself. So let's go ahead and turn on relative again. Okay, relative sequence numbers. There we go. All right, so what is the client doing here? The client is saying to the server, this is my starting initial sequence number. This is where I'm going to begin. I'm not telling you how much I have to send to you yet, but let's just start from my perspective. I'm starting here. Now the acknowledgement number, if we look over at our hex values, this is also a 4-byte value. At this point in time, that acknowledgement number is zeros. Why? Because the server hasn't sent anything to me yet. He hasn't told me where he's starting in terms of his sequence number on his side. I'm just telling him where I am starting. This is my initial sequence number value. Sir? The question was, does that depend on where you take the capture from? Great question. It can. Yes. That can depend. Do I have a box in the middle that's changing it or taking over that part of the TCP header? That's possible. So that's also another reason why it's nice to have client-side and server-side captures simultaneously, because you can see what was let go, how did it arrive, what was like on that side and how did it arrive. I wrote an article back a couple years, and I'm going to show you guys the trace file that it came from. And it was like, and I said, hey network, leave my packets alone. Because so many network devices now can muck with that stuff, so that's a good comment. But if I don't have anything on the network that's changing this stuff, that's the whole point with TCP. So he's saying, hey, this is where I'm starting from a sequence number perspective. There you go, server. You go ahead and tell me what you have on your end.
Okay, so
in fact, the SYN, the whole reason why it's called SYN, let's synchronize this stuff. All right, here's my sequence number. You send me yours. We're synchronized.
okay, let's go to synchronize our numbers here. I send you from the client, it sends you a sync number. You as a server receive that sync, and then you send me your another sequence number, your acknowledge, okay, which is having the SYN, SYNAC, SYNAC ACK.
Now, let's come down here. Okay, window size value. All right.
All right. So that'll be all for this video. Okay. Take care. Bye bye.